Hi, this is Arunamshu. Here I'll explain you how we applied the CRISP DM methodology and the best practices to successfully build a machine learning model for our company, which is a automotive product manufacturer. So basically, our presentation has been divided into six major bullet points. It's a background of the problem, opportunity evaluation, CRISP DM business understanding, validation plan, machine learning system design, and the potential risks in production. And the CRISP-TM business understanding or the CRISP-TM methodology has the six business phases or other sub phases: business understanding, data preparation, modeling, evaluation, and the deployment. So, what was the background of this particular solution? The company sold an automotive product for 20 years, over 20 years. However, for the last 5 years, the revenue has been stagnant and there is no gain in significant growth since the number of sales remains stagnant as well. The condition would remain same in the future if something extraordinary steps had not been taken. The company had lot of potential buyers, but with a limited number of resources, the sales team was unable to reach all the buyers. And also basically sales team did not want to target all the buyers just by assumption. So the sales team need to be able to quickly inspect and prioritize who can be the potential buyers and also need to normally research what are the factors that drive a potential buyer to be a buyer. And also they have another problem is the cost. So they want to minimize the cost. So now we come to the opportunity evaluation phase. So the business sponsors and the sales team reached to the development team, and the development team had several rounds of discussion with the business sponsors and the sales team, and they identified the primary three problems. The company was having stagnant profit because the number of sales had been constant for last 5 years. Next problem was there were a lot of customer leads, but the sales team could not reach all of them. Next problem, the sales team needed to know which customer leads should be prioritized. The next question that came up, is it feasible with the machine learning? Though the problem was a little bit complex, but looking into the domain, the machine learning driven analytics could help build a model or build a recommender system that will eventually and probabilistically predict the potential buyer of the automotive products, and thus will help increase the revenue of the company. The next question comes up, can the development team get the enough data to build the model or the recommender system? Yes, the company had data for sales and customer leads for the last 15 years. So there was enough data to build the analytics driven recommender system. Does someone really care if it is to be machine learning or not? So what was the business impact? The business team confirmed that the problem is gruesome and solving it analytically would have a high business impact. Then the question comes to the development team. Is the solution feasible? Yes, the development team confirmed developing a robust recommender system through the machine learning will solve the problem of reaching out to the potential buyers. Next comes the most important phase is the CRISP business understanding. So it has six major phases: business understanding, data understanding, where is the to and fro always between the step one, step two. Then comes the data preparation from the data understanding. Next comes the modeling, and that's a to and fro interaction between the data preparation and the modeling. The fifth step is the evaluation, and then basically to compare with the business understanding whether the evaluation is in tally with the business understanding. And the last step is if the evaluation is on the right track, then comes the model deployment in the production. So what is the business understanding? The development team had several rounds of discussion with the business sponsors and the sales team and documented all the findings in Atlassian Confluence and also in the Microsoft Office. And development team defined the success metrics to be SMART with the acronym. And basically they explained that the outcome will be specific, outcome will be measurable, outcome will be achievable, outcome will be relevant, outcome will be time bound. Now, what are the outcome metrics? The business goals and KPI. The company is focused on the following outcome metrics from the model. Gain the insight on what drives people to buy the company's product. Increase the profit by 10% year over year. reduce the annual marketing cost by 10%. And what is the output metrics from the model or the recommender model? That those are the machine learning model goals, KPI metrics. The machine learning goal is determined by the data mining and the data science team, and is a translation from the business goals. Build the predictive model with 80% accuracy. Build the predictive model with 75% recall. Build predictive model with 75% precision. Next comes the data understanding. On the data understanding phase, the data engineers, data analysts, and the data scientists gathered, described, and explored the data to make sure the data fits the business goal. And the deliverable of these phases were basically data description. That means what type of data it is, what are the different rows and the columns of data, and this particular exploration came as a report, and also basically validating the quality of the data, whether it fits for the recommender model or not. So you can see the summary of the data, and the summary of the data, basically we have these 14 columns, and we can see that whether those columns are basically good for the feature understanding or not. Now we see that this is the summary of the data, of the current data without any pre-processing. It has 40,000 rows, 14 columns, and these are the summary of the data for each column. There are categorical, they are integers, so different types of mix of data. So the particular data set has 14 columns. The flag column is actually the target column, which tells whether the customer was actually a customer or not, means it bought the automotive product or not. And then there are another 13, the feature variables or the predictors. So we did an early data exploration and data quality check to see if the data fits to the recommender model or not. The main purpose of this exploratory data analysis is to help look at the data before making any assumptions. It can help identify obvious errors as well as better understand patterns within the data, detect the outliers, detect the data trends, and also involves the visualizations and the statistical measures. It helps data scientists gain an understanding of the data, say beyond the normal modeling or hypothesis testing task. EDA analysis is essential for any research analysis so as to gain the insights into a data set. So this is the current data summary, and you can see from the data summary there are a lot of blank labels. Let's say in education, then in the marriage, then also child has sometimes the integers, sometimes the characters. So basically this is not a quality data that can help in building the recommender model. So you can see the customer psychology, the full data, the categorization, family incomes full data, the categorization. There are some interesting findings from the summary. You can see that the gender is male, female, and unknown. So, and it has been basically, it's not quite okay, right? So we have to know that whether unknown is required or not. Or child is basically 0, n, and y, right? So y is basically, a 0 is may not be a valid value here. So we have to determine all those things. So then comes the most important phase of the data understanding is the data preparation. So the data preparation has been divided into 4 major steps: data discovery, data cleaning or cleansing, data transformation, and the data enrichment. And this basically makes our collected data as a quality data. So after this is done, the final data basically will be ready. So there are certain benefits of the data preparation. There basically data preparation ensures that data utilized in any analytical application is clean and capable of providing reliable outputs. Data preparation helps identify potential problem areas with data that would otherwise go undetected. Data preparation helps management level employees, executives, and operations related professionals make better business decisions. Data preparation brings down the cost of analytics and data management. Data preparation prevents any repetition of the data when preparing it for use across applications. Data preparation helps a business ensure a better return on investment for business intelligence and its initiatives. Some of the examples of the data cleaning: change the missing and empty value of the education and house owner and the marriage into explicit unknown, where basically it was you or something. Make you value in all categorical columns explicitly as unknown. Then in the age category, 1 underscore UNKN should be changed to unknown, 2 underscore less than 25 should be less than 25, etc. Clean the mortgage category from 1, here index has been appended to the category. So 1 low should be modified to low, etc. And after doing all this data cleaning, transformation, and enrichment, This is the final summary of the data which is ready for the data modeling. So at this stage, basically we talk to the sales team that whether the for every column, if there is an unknown level, whether that those rows are valid or basically any usefulness they have it or not. And sales team confirm after examining that they are not valuable. So we basically clean any data in any column with the level of unknown. And this is the final version of the data. You can see none of the rows are blank and all the columns are properly in the proper shape and proper formatted. So data understanding, as expected, CRISP is not a linear process. We can go back and forth between the process to make sure it fits the business and data mining goal. Here we go back to the data understanding phase to further explore and analyze the data before we start making a machine learning model. And then the next important step is exploratory data analysis. It helps in exploring and visualizing the insight from the data, and that gives a benefit to all. Here basically we see each and every column on the predictor side, how much influence it has on the target, means the flag column, that whether that particular feature is influencing the target variable, whether the potential customer will buy or not. So we did an EDA with the house valuation distribution. There was no definite correlation because whose house valuation is basically less than 250,000, they sometimes bought it, they sometimes didn't buy it, and whose house valuation is more than 2,50,000, sometimes they bought it, but most of the times they did not buy it. So there is no definite correlation coefficient with the target variable of the buying and not buying. Next, basically, we examine the buying habit with the education level. It's a categorical variable, so we basically had a heat map. That also definitely did not tell us any particular correlation coefficient. The third one, we took up the occupation, whether basically it has any correlation with the buying habit, and also basically it was very high, so definitely it has a high correlation coefficient with the buying habits or the target variable. In this way, you can do for all the 13 feature columns along with the target column flag and can find out which particular column basically has the best correlation coefficient. Next comes the important phase called modeling. And on the modeling phase, we'll start creating the model to find the pattern inside of data and to make future predictions for business purpose. The deliberation, the deliverable or results of this phase should include the modeling techniques, and the assumption is what kind of modeling techniques you are going to take. Depending upon the outcome of the problem, it can be a classification or regression or a clustering or a neural network model. And here basically we need whether it's a potential buyer or not. That's a binary classification. Then we describe the model and then we evaluate the model. And the model evaluation is basically iterative step driven. And what is exactly a model? A model is a representation of the world. Since it's just representation, some information may be lost and may not be very accurate. However, it still is useful for some purpose. So the benefits of the model is that it helps in automation. It helps to remove the human bias. There are always scope of improvement. The data handling is efficient and the wide range of applications this model can be attached to. Now, this model training, an important thing as part of the model training is the k-fold cross validation. Generally, when you build a model, to train a model, we divide the existing dataset into training and test dataset in the ratio of 80-20 or 70-30. Here we have 40,000 rows, but we should not take a iteration 1 as the final one. So we will have the k iterations. That means k set of cross validation. Our first data train set has 13,000 rows almost, and the test data set has 2,318 rows. And the rest of the things are basically under the k minus 1 iterations. So now comes the model fitting. We basically did two models here, a decision tree, a particular single model, and the random forest, and ensemble of the models. Ensemble of the models, we took the family of the models because it sometimes gives the better performance than the decision tree. But why we took the decision tree first? To see if a single model is giving the better performance or not. And we will see in depth how things are opening up. So we used two recommended models. One is decision tree based and there is a random forest based. The final model accuracy of the decision tree model was 0.79. Final model accuracy of the random forest model was 0.84. And this is at the end of k iterations. And the expectation was that the accuracy should be 0. Greater than 0.8. So definitely the random forest was the better choice, but there are several steps that have been followed to reach into this conclusion. So in the decision tree model, the following two attribute selection measures were used to build the train, decision tree based model and the recommender model. The Gini index and the information ID3, and also we calculated the entropy value. This helped us basically determine the root and the other branches of the decision tree that you will see in the next slide. So you can see here that how we build the decision tree. Customer psychology, then the education, then the gender. These are the predominant branches and the links. Next, we go to the random forest model. The data science team basically took the random forest model, which was an ensemble of the two algorithms, bagging and boosting. And bagging basically is a homogeneous weak learners model that learns from each other and independently in parallel combines them for determining the model average. Boosting is also a weak learners model but works differently from bagging. It basically takes the feedback of the previous models and corrects it or the updates it and make a better performance for this. And basically the output of the random forest model, it comes through the importance of the Gini score, and as Gini score decreases, that means that particular feature is predominant. Then the main thing comes is the how to evaluate the model or the model evaluation. This is a classification model. We evaluate the model by looking at how many of their predictions are correct. This can be plotted into something called confusion matrix, where the prime thing is that predicted buyers and the actual buyers. So we have our main interest would be true positives, false positives, false negatives. True negatives are not that kind of importance unless and until we have almost 80% true negatives. Then our the customer target base is not right. So we'll focus on the true positive, false positive, and the false negative. So true positive is basically the model predicts the customer will buy, and the prediction is correct. False positive is that the model customer prediction is that it will buy but actually did not buy. True negative is that the prediction was owned by and exactly the customer did not buy. False negative is that model predict the customer will not buy but actually the customer bought it. So you can see basically the true positive is 1648, false positive 791, true negative 581, and the false negative is 298. So here basically we are focused on the actual prediction. So that means it's a how many of them are right predictions. That means the true positive and the true negative, and basically among all the data sets. So in the first iteration, it came out as 0.67%, means 67% are actual accuracy of the model, buy or not buy. And then comes the recall and sensitivity, where the focus is basically how means among the predictions, how many of them were true, and basically how many of them are basically actually true. So that becomes basically true positive and then divided by the actual positive. So it became the 0.84, means 84% will buy and 60% won't buy. Next comes the precision. Precision basically the actual right prediction among all the predictions. So right predictions means the buy, right? True positive. So it's a 0.67 or 67% that will buy the product. So the iteration one is still not fully means the meeting the business understanding. So we'll go for another k minus 1 iterations, and basically we reach to the final model accuracy as we described earlier. So this was the output of the first iteration. You can see the comparison between the decision tree and the random forest, and see that the accuracy and the precision are not that close to the expected outcome. So we need to run for another k minus 1 iterations as we discussed earlier. And basically what we basically assigned is that for a test, the getting an actual customer, the revenue is $100,000. Approaching a customer is a $600 cost, and the profit is $400. 1000 minus 600. And for a true negative, definitely we are not approaching the customer, so there is neither a cost nor a revenue. Then review the overall process. The overall process of data mining is quite smooth with some flaws that we found. The dirty or improper data was there. Underperforming model was there for 1 or 2 iterations. Data gathering was not in real time and it was too much historic. So the final decision that we reached after reviewing the project that we need to improve the model and release them for the real use before release them for the production. Release the model while also developing a better model. Create a standardized data input procedure. Present a full report of data mining project. Deployment is very much needed for the model outputs to be accessible in the real time by the business users and the sales team. So for that we need to build an API that will basically deploy the model, and then the output of the API should be visible in a dashboard. So this particular phase includes the deployment plan, monitoring and maintenance, final report. In the conclusion, the CRISP-DM methodology is a long and detailed standard that will make your data mining project fits your business needs and document it properly. It's not a linear method. You can always go back to the previous step if you found an issue or need to renew some goals and process. Now comes the validation plan with the customer. The customer is the sales team of the automotive product manufacturing company. We let the sales team know that we had sufficient predictor data available to make the recommendation on whether a lead will convert into an actual customer. We will align the cost revenue structure with a recommender system. Cost of approaching a potential customer is $600. Revenue generated from each actual customer is $1,000. Profit from a customer is $1,000 minus 600, $400. Loss from a wrong recommendation. That means a recommended and approached customer is not an actual customer. Is minus $600. So our model recommender model will have 80% accuracy, let's say. So let's say we have 10 customers, 80% accuracy means we can predict 8 customers who will become an actual customer. One is a wrong prediction and one basically is a right prediction that it won't be a customer. So our aggregated or accumulated profit is $400 into 8 and minus the cost of approaching a wrong customer is $600. So it's ultimately $2,600 for every 10 customers. Since we have a zero cost and zero benefit for a negative prediction, we can skip the calculation. So now the phases that I described earlier, it will be an iterative phase, and this phase, iterative experiments should involve 5 levels. Meta level, continue to improve the data and the features. Macro level, explore different model families and ensembles. Micro level, cross validation to tune the model hyperparameters. Model level, fitting the model parameters, and human level is improving the developer skill. So here you can see the data management, data governance, and the data lineage steps that we basically followed. And at the end of data management steps, we store the data. So and also then from the stored data, we applied domain mapping and the feature engineering experience to create a feature store, and the features from the feature store will be used in the model building and training. And the macro level is trying different models. So basically, using a single model sometimes may not give you the better output. So ensembling models was one of the advanced methods that we take, and the data scientists developed the recommender system initially with the decision tree based model and later with the random forest model, which is an ensemble of bagging and boosting. The ensemble of models provided better model accuracy and precision with the careful cross validation. And then we basically tuned the hyperparameters for the two models. For the decision tree based model, the hyperparameters was max depth, min sample split, max slip nodes, max features, and the hyperparameters for the random forest based model was max depth, min sample split, max slip nodes, min sample slip, n estimators, max sample, and the max feature. And then comes the feeding the parameters. The parameters are like the loss, cost, function, branch location, and we use the gradient descent algorithms to basically calculate the loss, cost function, and the branch location of a model. And this final set of parameters are the fitted parameters for the best version of the model. Now the ML system design. We discuss the business sponsors and the sales team about the following: the importance of the outcome, the scalability of the outcome, how quick they want the outcome, and how accessible the outcome they want to be. Based on the responses of the above bullet points, we made the decisions about the machine learning system design. So cloud or edge. The company chose the cloud as the machine learning platform for the following reasons: improved collaboration, increased efficiency, scalability, in-depth and real-time reporting analytics, reduce and hardware cost. The company did not need the solution proximity to the device, so it did not opt for the edge AI. Next comes the offline learning or online learning. The company chose the online learning for the following reasons: real-time data management and data governance, auto retraining of the model, volume, velocity, variety. Batch predictions or online predictions. The company wanted to accelerate its business decisions and make the predictions immediate and in a timely fashion. So it wanted a real-time online predictions. This was a ML system architecture. The first step was for the raw data storage in the data repository. Second step was data orchestration, means the data preparation, data transformation, cleansing, understanding, and then basically storing that into the feature store after extracting the features from the data, and then applying that feature store in the fourth step for the model building and training. And after the model building and training is done, in that basically we store the experiment results in the experiment store the models in the model registry, and from there model is deployed and ready for serving, and then that model serving is being integrated to the user dashboard for everyone's view in a collaborative way. So technology and the tools used, we use the programming languages Python, R, model building and deployment scikit-learn, NumPy, Pandas, Matplotlib, Seaborn, Plotly, SpaCy, NLTK, Spark, API framework Flask, user interface Angular, data version Pachyderm, database MySQL, code version tool GitHub, collaboration tool Atlassian Confluence, MS Office, issue tracking tool Jira, Scrum methodology, Sprint and Kanban. Potential risks in production, the drift concerns and the other potential issues. The following are the potential issues that can happen in the production. The target drift or the concept drift, it happens when the model gets downgraded. So you also examine why the model, how much the model degradation happened, and what was the cause of the model degradation. Data drift is a type of drift where the properties of the independent variable changes due to seasonality changes, consumer preference, pandemic, and other new product appearance, all other things. Operational issues means upstream data changes refer to the operational data changes in the data pipeline. Example of that, a feature is not getting generated, or a feature basically is obsolete now, or a new feature basically is not being generated properly, or let's say memory is exhausted, server is busy. So these are all the aspects I have covered. Thanks for your time.